Hello friends, thank you for watching this video. I am Muhammad, and in today's video we're going to be discussing API rate limiting. We're going to be discussing why do we need them, and then we're going to be discussing the different way we can actually implement rate limiting into our API. So let's get started. So what we're going to be needing here is we're going to be representing a client and server relationship. So let me get a laptop, for example, and this is here a laptop, and this is going to be, for example, representing my client. So this is going to be my client. And for simplicity's sake, I'm gonna put like I have 4 different clients. 1, 2, 3, and 4 clients. So here what I have is I have 4 clients, and these 4 clients basically they're gonna be communicating with my server. And inside my server, they're gonna have an API. So now that I have my client and I have my API ready, whenever my clients wants to do any types of call, they need to actually call my server. So for example here, I can have one client calling this server here for request, then I have another client also calling the server for request, similarly to all of these clients calling for request, and lastly this one. So if every single one of these clients is going one single call per second, that should be fine. My server is able to handle it. So a server, as we can see here, has certain limitation when it comes to memory, which is going to be equal to RAM, and CPU for processing. So this is going to be my main limitation for my server. So in case one client is doing one call, that should be fine. If another client also doing one call, that should be fine. And third one as well, and third one as well. So now I can see I have my clients, every single one of them is doing one call. My server and my API is able to handle this. So let's say the limitation of my server is 100 calls per second, and everything other than that, my server will just crash. So let's say my client all of a sudden decided that, okay, they wants to utilize more of my server functionality, and they increased their utilization from 1 to 25. So that's a very good implementation. It's still within the limits of my API, and I'm still able to give back my the response. Then client number 2 decided, okay, I also have a good utilization. I'm gonna increase my utilization from 1 to 30. So now we are more than halfway of my resource capacity. So here a server started to work a bit harder in order for it to actually return back the response. Now we have client number 3. Client number 3, okay, perfect. I also have a perfect opportunity here. I'm gonna increase my utilization from 1 to 30. So now basically we have almost more than 75% of utilization. So now the server is actually really struggling and into start to return back the response. Now we have our final client. Final client said, okay, I'm also gonna need a 20% utilization of my resources. So I'm gonna basically send a 20 more requests. And basically from there, we can see now the server we have exceeded the number of allowed requests. So now we have 105 rather than 100. And now the server is completely gonna be overwhelmed and the server is gonna crash. So the application here is gonna say a 400 or 500 server error, because basically the server is not able anymore to process any of those requests. And this is basically what happens when we don't have any types of limitation on the number of requests which is going to be coming in. Because this server is actually going to be compromised of certain memory and CPU, we're not going to have basically a carte blanche or like an open-ended capabilities of how many requests we can do per second. If we are on the cloud, we can actually have automatic scaling for this server. Again, this is all theoretical. So if, for example, if I'm on the cloud, I have a capability to scale, but whenever I scale more on my server, I'm gonna have to pay more money for it. So for example, if in order for me to serve this, it means that I need to have another server. And if one server is costing me, let's say $50 per month, to having a full another service to handle this, that's gonna be another $50 as well. So that's $100 just for an extra 5 requests, which is gonna be coming in, which is not really feasible. And this is where we can see the problems that we might face whenever I have an open API where anyone can call my API without actually having any limitation on the number of requests any client can do for the server. So how can we solve this? So lucky for us, we have something called rate limiting. Let's change the color to blue as a defense. So within a rate limiting, and there's different ways of rate limiting, which we're going to be discussing in a bit more details, but in essence, rate limiting limits the amount of requests that any client can do to the server. A rate limit, for example, would say like every single client is allowed to do a certain number of calls per second, around those lines. So basically a rate limiting, we are not allowing, if the client number 1 wants to do 25, we're not allowing them to do that 25 at the same time. What we're doing is we're basically trying to break down this 25 into chunks of 5, 5, 5, 5. So per second, we are only receiving a handful of requests coming from a single client. So for example, here, instead of having 25, the way we're gonna be processing, it could be 5, 5, 5, 5, and 5. So this is gonna be the equivalent of having a 25 call. So instead of having directly 25 call, with the rate limiting, I'm gonna have five requests of 5 every time. Similar to what you have here, instead of having a 5 request, I'm gonna have 6, and similarly here, and here I'm gonna have 4. So that way what I'm doing, I'm actually protecting my server by actually trying to limit the amount of requests coming in. And first of all, I'm saving money because basically my server is not scaling, so I'm not really utilizing more resources, so which I have to pay for. Second, I'm actually protecting my database because also the database resource is going to be utilized. It's going to have a lot of pressure on it in order for it to provide all of this information back. So we can either here like have a high utilization of the database, or for example, I could have a read lock on it. So there's multiple scenarios where my database could face problems. So that's why it's also good to have rate limiting implemented on it to protect it. And lastly is to protect my API. There's a lot of malicious utilization of APIs. So for example, if someone wants to take my API down and wants to prevent anyone else from utilizing it and wants to make it unavailable, if I don't have any rate limiting, let's say I have this malicious client. So this malicious client here, I'm gonna make it in red because it's malicious. And this malicious client decided that, I'm gonna say it's a bad actor, decided for any reason that they want to break my server and they want basically not allow anyone to utilize it. So what do? They start flooding my server with requests. They start actually doing all of these different requests to my servers. And for example, instead of having a normal number of requests like 20 or 30, they start sending thousands of requests per second. And we can see here 1,000 requests per second on a server that can handle 100 requests per second is gonna break, and it's gonna turn the server to completely stop working. And this is why rate limiting will actually protect my API from any bad actors or anyone who's trying to actually break down the server that I'm trying to build. And this is why it's really important for us to actually protect the APIs, because first of all, we don't really want to damage any of our data. We want to make our API available 24/7 for all of our clients, and we want to prevent any bad actors from basically breaking our applications. So how can we implement this rate limiting? So there's a lot of different ways where we can actually implement rate limiting for our applications. And the first one we're going to be starting with is going to be fixed window. So fixed window means here that we have a timeline. So here we can see I have my timeline, and within this timeline we can say that this timeline is going to be every 5 seconds. So every 5 seconds there's going to be requests coming in, and within this request coming in, I'm allowed to process 6 requests. So every second or every 5 seconds I'm only allowed to process 6 requests. So once this timeline has finished, so once the first timeline has been processed completely, then I'm going to have another timeline, or basically another time window of 5 seconds, which I'm only going to be processing request. So what happens if a request comes in and I'm still waiting within my pipeline? So let's say I'm already in my window here, and I am in the 2.5 second window time frame. So I am here in the 2.5 second, and a request comes in. So what happened to that request which is going to come in? The request will not going to be able to go directly into my queue, into my timeline, because this timeline has been closed and it's only going to accepting a certain number of requests coming in. So this request will go into a queue. Any subsequent requests will also going to be going into a queue. The requests will keep piling up as long as my time slot is still in process, and it's going to keep piling up and piling up. So this queue will also going to have a limit. So for example, here we can say the number of requests coming in for this queue will only accept, let's say in this case, 6 requests. So once we hit the 6 requests, the queue will be full, and basically within the 6 requests, our time window will also going to be utilizing to process all of the incoming requests that we have. So once this time window has elapsed, so what's going to happen then? Then we're going to be basically having a new 5 second timeline. And then what's happened is I'm going to take requests from my queue and start processing here. And this is what fixed window means. Fixed window is within a certain time frame, which is going to be 5 seconds in my scenario. I'm only allowed to process certain amount of requests, and all of the subsequent requests will go into a queue. So you might think to yourself, okay, great. If that's the case, what's going to happen if we said the queue can only handle 6 requests? What's going to happen if a 7th request come in or an 8th request come in? How will my application handle it? In case another request comes in and the queue is already full, this request will be completely rejected. And if another request comes in, and this request will be completely rejected. And the error that these will get is going to be the error of 429 too many requests. Implementing rate limiting on these requests so we can actually prevent our APIs from getting flooded. So these too many requests that we're going to be getting here, and all of these requests which is going to be coming in, are going to be completely rejected. Perfect. So we can see that this is actually a good implementation and a good way to protect our service. But this will not protect it 100%. Why? Because here, as we can see, we are thinking that the requests might come all sequentially. But what happened, which I'm going to make it like this, what happened if all of the requests suddenly come all in a single burst? So we can see here, 5 requests or 6 requests came directly into a single burst, and my application was able to process these 5 requests, and they were able to finish within the first second. So this means that once my application has finished it within the first second, I'm going to have roughly 4 seconds of an API doing nothing. So I'm going to have all of this wasted space, all of this wasted resource inside my API, which I'm not able to do anything. Why? Because my API was able to finish everything within a single second, and this means that I'm not really optimizing my API to the maximum. This can work. This implementation of a fixed window can actually be very beneficial in certain scenarios, but as you can see, it has certain limitations that we might need to think of. So depending on the need and depending on how you want to actually your API to respond, you might actually consider this, or you might consider another one of these implementation. Now that we have understood what fixed window means, let's move to the other types of rate limiting that we can actually implement, which is going to be called a sliding window. So a sliding window means it's pretty straightforward. It takes the same example as a fixed window, but we can say that for every single second, we can only process 2 requests. So for example here, if a new request wants to come into place and we are already processing it, we start adding it into a queue. So in this scenario, I have my timeline, and I can say, for example, for a certain amount of time, I can actually process a certain amount of requests. So we can see here that this is the time frame that I am in, and I can see I have 2 requests. So once this request has been completed and this request has been finished successfully, what I'm going to do is the sliding window will go in, and this will move forward, and this now will become active, and this will become active for it to be processed. And then once this has finished, this will also now be turned into completed, and then this will move into the next step, which is going to be here, and so on and so forth. So the sliding window in many ways is complementing the fixed window that we have discussed before. It has the same structure of a queuing mechanism where actually all of the requests will be queued in, and we can see here it can actually allow us a bit more flexibility when it comes to handling all of these incoming requests. I would say the main downside to the sliding window, it's going to add a bit of an overhead for the full response time, but this is also the case for every single types of rate limiting implementation that we're going to be doing, so that's fine. The second one is going to be, the third types of rate limiting is going to be concurrent. And concurrent is going to be a bit more of my preferred choice, to be honest, on what type of implementation that we can actually do within a rate limitation. So here we can see that we have 6 different users, and all of these different users are calling my API simultaneously. So we can see here we can have 6 users, and all of these different users have these requests coming into place. So with a concurrent request, I can say that my application can handle a certain amount of requests. So I can say every single application or every single user is only allowed to have 5 requests coming in simultaneously. I'm not limiting on the number of users which are coming in. I'm limiting it on the number of requests that every single user. So here, before in all of the different examples, I'm not really trying to limit the requests that which I'm processing based on the users. I'm user agnostic, so I'm just basically taking any types of requests coming in. On the other hand, with concurrent, I'm actually doing the limitation based on the user, who is doing the request, because every single user has a limited stock of requests they can come in. So I can say, for example, every single user will have 5 requests to come in. So every single request that they do after that, it's going to be completely rejected, and they're not going to be able to process. So this is why we can have within a concurrent request, we are not actually limiting new users from coming in. So let's say I have user 7, user 8 have joined, and these users are only doing 1 to 2 calls. They're actually able to join and do those requests, even though my API is already fully backed with all of these different users. I'm not forcing any types of limitation, because within their own allocation slots, they are actually able to do this request. If they exceed it, it's gonna fail. So here we can see that user 4 has already another 5 requests coming in, and all of these 5 requests are gonna be completely rejected because basically they are exceeding the 5 allowed. So once these, let's say this one and this one has completely completed successfully, so I'm gonna say green for them to be completed successfully, what's gonna happen? Then the limitation for these is also gonna move forward with it. So here we can see now they have another 5, and this will now become able to be processed in case they do a new request. So here we can see that with this, every time they finish the slots number that they have, they get basically a new slot of requests, and they got to come in, and then based on that they will be able to process more and more requests. Another cool feature about this, let's make it back. So in case my request comes in, so instead of directly rejecting and saying that there's going to be too many requests, what I can do is I can put these incoming requests into a queue, and it's going to follow the same as the time fixed window rate limiting. So basically these will go into a queue. I can specify if this queue gonna be FIFO or LIFO, first in first out or last in first out. And basically within this queue, what I can do is I can just store them, so I'm not rejecting them if my queue is full. And then from that point I can say, okay, you have a 4 to 9 rate limitation, so you have done too many requests and we're not going to be able to process a new request. But other than that, I'm actually able to keep a track of all of these new incoming requests, and once I keep track of all of these new incoming requests, I'm actually able to resend them to their specific client based on their utilization. So I can know, for example, these 2 belong to client 1, this belongs to client 4, etc, etc. And basically in this way I'm actually able to manage these incoming requests. I am actually able to protect my API, and I'm giving flexibility to all of my users for them to actually have capabilities to use my API endpoint without forcing a limitation. If one user decided they want to basically do a lot of calls and I don't want to prevent all of the other users, I'm basically here sharing the amount of resources among my users, and I'm limiting the number of requests per users. And this is why this is one of my favorite way to implement rate limiting. And the last rate limiting approach that we're going to be discussing is going to be the token-based rate limiting. So what's a token-based rate limiting? So let's take a look at this example. So we can see here a request will come in, and there's going to be, whenever a request will come in, we're going to be checking how many tokens do we have. So basically we say, when we set up our API, we're going to say for every single time frame, like for example for every 5 seconds, we're going to have roughly around 10 or basically 30 tokens. So for every 5 seconds we're going to have 30 tokens to be utilized. So whenever a request comes in within these 5 seconds, it's going to check, do I have any tokens available? Yes. If they do have a token available, the request will be processed, will be forwarded for processing, a token will be removed from the box, and then the request will be processed. Another request will come in, do I have any tokens to be utilized? Yes. And then this token will be actually utilized, and then the request will be processed. So let's imagine now we have reached our 30 token that exist, and we are still within this 5-second time window. A new request will come in. Do I have any available tokens? In this case, no, so the request will be ignored. And this is what token-based policy. So token-based is not going to be preventing the incoming request based on a user. It's not going to be preventing the incoming request based on the client that we have. It's going to actually base it on the number of tokens, or basically on the amount of requests that we are actually allowing to be processed within a certain amount of time. And this box here that's going to be storing all of these tokens, it can be refilled every single time. So if we can say every 5 seconds we're going to add another 30 tokens, every 2 seconds we'll start filling it up again. So there's different ways where you can actually handle the token-based policy. A good case scenario for me to utilize token-based policy, if I don't really know the amount of clients who's going to be utilizing my API, so I don't really want to allocate resources based on the client. So this way is a good way to actually allow, if for example I have 2 or 3 different clients and one of them want to really do a lot of calls, that way I can actually utilize this. The main downside of this, if I have, for example, greedy clients who, let's say I have one client who wants to do like 100 call, they can actually do 100 call and basically deplete my token before it's being refreshed, before any of my other clients can do any request. So we can see this could be one of the limitation, but again, it's always going to be a delicate of what do I want to achieve and what are my use cases, and based on that I can select what type of rate limiting algorithm I can utilize within my APIs to protect it from malicious utilization. So I hope this video was helpful. It was mainly about understanding those different techniques of how we can actually protect our APIs from malicious malicious users and how we can actually have more control about the incoming requests. If you have any questions, please put them in the comments down below. If you want to see how to implement this, I will link the video where I go step by step about the implementation of all of these different rate limitation within .NET. I'll link it here somewhere in the description below so you can actually go watch it. That's a full implementation with code. This one is a bit more about the idea of rate limiting and why do we need them. So thank you very much for watching, and any questions, please make sure you put them in the comments down below. Have a great day.